Hi, I'm Shakira, and this is my quiz 5. So for question 1, I was asked, name the following compounds according to IUPAC rules. Be sure to indicate stereochemistry when appropriate. So for the first question, we were given 2,2 dimethyl propyl cyclopentane. And the way we found that was by numbering our pentane ring. So here's my model. Numbering, it was kind of, sorry. Numbering our pentane ring, starting with the with having the substituent at the lowest number. So this will be 1, 2, 3, 4, 5, and then this represents my 2 methyls hanging off. So this is where the dimethyl came from. And then this is my propyl. And then this is my cyclopentane. Okay, so for question 2, we were asked to draw sec-butyl bromide. So right here, I have my H3C, so HH, and then my 3. And then this is representing my bromide, and this is representing the hydrogen that's behind it, which you can't really see when you draw it out. And then this is my CH3 at the end, which makes it. For question 3, we were asked to draw the lowest energy, which is the most stable chair conformation of the given compound, which was cis-1 isopropyl 2-methyl cyclohexane. So this is the figure that I drew. So starting off with the isopropyl, you always have to make sure that you number, starting with the lowest number. So I put the 1 here, and the isopropyl, and then the 2 being the hydrogen, and then the CH3. So there, as you can see, these are both in equatorial positions, which would make them the most stable. And the cis basically states that that both substituents, which is the isopropyl on carbon 1 and then the methyl on carbon 2, are on the same side of the ring, which opposed to them being on opposite sides. So this is the basic drawing of the chair structure, and everything is numbered as well. For question 4, we were asked, the following compound has 1 stereoisomer that is a meso compound, so draw the isomer. So this is the isomer I ended up drawing, and a meso compound is a molecule that has 2 or more chiral centers, but is achiral because of its plane of symmetry. So given our plane of symmetry with both of the dimethyls going different ways, it doesn't give them an even plane of symmetry, which makes them achiral. For question 5, we were asked what was the relationships of the following pairs of compounds. I found that in compound 1 opposed to compound 2, given that the chlorines were represented with 2 wedges rather than dashes, their position actually was trans compared to 2 with the dashes, which made their position cis. So because of that, I named them diisomers. I also named them diisomers because they are not mirror images. For 3 and 4, I found that because the different connectivities, like how they have different standpoints of where they're connected, I named them enantiomers because they're non-superimposable mirror images. So because they're in different positions on each one, it makes them enantiomers. Okay, and for 5 and 6, as you notice, there's different connectivity here. So we have a wedge on 6, and then we have a dash on 5, which makes them enantiomers because they are, they have the same connectivity, but they have different arrangements. For 7 and 8, they're both cyclohexanes in chair formation, but they are 2 different representations of the same compound, which actually makes them the same compound. For question 5, we were told to identify the appropriate configuration for each one of the following compounds. For the first one, we have bromide, and then there's a hydrogen that's always coming off of it that's actually behind it, which is why it's not pictured. And then we have a double bond right here, and then we also have I think it's a CH3, I believe. So I numbered them according to the highest atomic number, I want to say. So bromide would be first, and then the double bond would be next. So I found that it would end up going clockwise, which would give us the R configuration, but you have to flip them because there's a hydrogen present, so it would give us the S configuration. All right, and for this one, I ended up getting E because after I numbered my my substituents, I found that it's going in the R position, but I actually got E because there isn't a chiral center, and because of the hydrogens and the carbons, it would cause a transposition, which is why I got E. All right, and for this one, I got S because as pictured, there's a OH that is in dash position coming off right here, so that would be my 1. And then we have an oxygen that's double bonded, which is why I got 2. And then we have the carbons right here, where I got 3. And because the OH has a dash position here, the H behind it, so the hydrogen behind it would get a 4. And it would be in a wedge position. So I found that it would go clockwise. It would go counterclockwise, which would give us the S position, but it would end up changing to R. Okay, for question 6, we're asked to complete the Fischer projection for compound A. So right here is my HOCH2, and then this will be my hydrogen, which is behind the OH, which is dashed. So this OH is going towards the back, and this hydrogen is going towards the front. And then we have my other OH going towards the front since it's in wedge position. And this is the hydrogen that's directly behind it, which is in dash position. And then this is my, excuse me. These are my oxygens for the double bonded oxygen. And then this is my OH. In order for us to rotate this to Fischer projection, we have to go like this. So everything would be repositioned. So this would be CH2OH, and then this would be my OH going towards the back. And then it's my hydrogen. It's my other OH, and then it's my hydrogen going towards the back. My double bonded oxygens and my OH. And for number 7, we were asked if the following compound was chiral. I found that it wasn't because there's no plane of symmetry in the structure, so therefore it can't be chiral. Okay, so lastly, we were giving a Fischer projection for the last question. So starting off, I numbered my compound as always. So I found that the CO2H is going to be 1. And then the H2N would be in the second position, and then the CH3 would be in third, and the hydrogen would be in fourth. So therefore, it would be moving like this, which is counterclockwise, so that would be S. But since there's a hydrogen, it would flip to the R position. And I found that it wasn't chiral because chiral means that it would have, I found that it was chiral because chiral has 4 different groups attached to it. So that would be based off of the configuration in which it did have 4 groups attached to it. And I did find that it did have an enantiomer because there is a mirror image that is not superimposed to that. So thank you very much for watching, and have a great night.